This is a video walkthrough of splatbench, a web-based benchmarking system for 3D Gaussian splatting deployment. The tool loads a reference splat beside a test splat, allowing visual inspection and runtime measurements to happen in the same browser workflow. This gives researchers a standardized and simple way to compare splats on the web, whether they are evaluating new splatting algorithms or studying splat compression formats. For example, users can change viewpoints and inspect visual differences in detail. The core view is a synchronized comparison. The same scene is rendered from the same camera viewpoint, aiding easy visual comparison. An A/B slider allows users to carefully inspect differences in specific regions of two splats. The camera viewpoint stays the same across both splats as the split is dragged, so thin structures can be inspected from the angle where artifacts are clearest. Splatbench also supports rapid changes to the comparison setup. By changing the test splat in place while maintaining the same viewpoint, the tool shows when a winning splat depends on what the viewer actually inspects. While the reference splat stays fixed, varying the test splat and viewpoint reveals how each format behaves across different parts of a scene. The same workflow can be used across curated benchmark scenes. In our representative evaluation study, we observed that different scenes emphasized different characteristics. Flowers stresses fine structure detail. Garden carries the largest files and slowest loads in the portfolio. Train tests text and edge preservation. An example finding: the .splat format softens lettering most. This lets the benchmark test whether a splat behaves consistently or whether its strengths depend on the scene being viewed. Splatbench is not only a viewer. It records browser-side quality and runtime evidence, then exports repeatable benchmark data for analysis. The same interface can build out a benchmark matrix from a scene pair, producing CSV evidence traceable to scene, viewpoint, splat, and browser context. These exported measurements help practitioners make better deployment decisions and let researchers produce reliable evidence. PSNR and SSIM for image quality, frame rate, frame time, memory, load time, and file size for runtime. For example, in our representative benchmarking study, the same browser-side measurements show that scene, viewpoint, splat, and browser deployment details all make a significant difference to performance. Splatbench makes such trade-offs inspectable, repeatable, and exportable.